This video is part 1 of the discussion on polymorphism in joint OpenGL graphics shapes. In this video, we'll have a brief review on inheritance and polymorphism. In part 2, we'll discuss the use of polymorphism to draw different open graphics objects.
In C++, inheritance is a relation, meaning that a child class could use the functions or data members of its parent. In this UML diagram, G-object is the parent class, line, triangle, and rectangle are children. In C++, the parent is usually referred to as the base class, and a child is referred to as a derived class. In Java, they are called superclass and subclass respectively. So we can say that line is a G-object, triangle is a G-object, and so on. In C++, we have 3 kinds of access modifiers. Public functions and data members are visible to all other classes. Protected is visible to the current class and its children. Private is visible only to this class. By the way, another relation used in a C++ program is aggregation, or has a relation as shown in this diagram. Here, enterprise class has 1 or more department class. A department class has 1 or more employee class. Polymorphism refers to the ability to have 2 or more functions, with the same name, doing different things, depending on which class the function is invoked. Here, poly means many, morph means changing forms, or shapes. Here's a simple example. The plus operator can act on integers, or floats, or strings. Benefits of polymorphism include 1. Allowing one to redefine existing behavior, but preserve the interface. 2. Allowing derived classes, or children, to override the behavior of the base class, or parent. 3. Allowing users to make calls on objects, without knowing which part of the inheritance tree it is in. In C++, a class that declares or inherits a virtual function is called a polymorphic class. A virtual member is a member function that can be redefined in a child. Here's a C++ example. We define a parent class, which has a virtual function defined by the keyword virtual and a non-virtual function without the keyword virtual to print out different messages. We define a child class and functions printing out these messages. When executed, it generates these outputs. For a non-virtual function, the parent function is selected and is determined when we compile the program. This is called static binding. For a virtual function, a corresponding child function is selected, and this is done during program execution or runtime, as the parent could have more than one child. This is called dynamic binding. Let's compile the program and execute it. So you can see that it generates the outputs discussed.
Okay, now let's save this and then compile it and then execute. So this is the output. Okay, so thank you for watching. Okay, bye.